Okay, we're moving on to lesson 2 under your M2-T1 ratios tab if you're working in OneNote. It's called 1.2 Comparing Ratios to Solve Problems. If you're working out of your textbook, you'll want to make sure that you're on page M2-25. All right, Going Strong is the name of it. In this one we look to compare ratios. So we've got a big word here we're going to use called qualitative ratio reasoning to think our way through and to help compare ratios to see which one is more or less as we go through this. All right, let's keep going on. Lemonade. Tammy's glass of lemonade has a weaker tasting lemon flavor than Jen's glass of lemonade. The shaded portion in glass represents an amount of lemonade. All right, so Tammy's is weaker, Jen's is stronger. If 1 teaspoon of lemon mix, there's my little spoon, if 1 teaspoon of lemon mix is added to both Jen and Tammy's glasses, which glass will contain the lemonade with the stronger lemon flavor? Go ahead, think about it in your head. Which one's going to be stronger? Write down your answer. All right, well, hopefully you said that Jen's glass will be stronger. And the reason being because they have the same amount of liquid. And if they have the same amount of liquid and you add, and the same one's already weaker and stronger, and you add some to it, then of course it's going to have the stronger tasting one. All right, moving on. Let's go to lesson or activity 2.1, qualitative comparison. Say that, qualitative. It says in this activity you'll compare ratios without measuring or counting quantities. When you reason like this, we call it qualitative reasoning. The shaded portion in each glass represents an amount of lemonade. Answer the question and explain your reasoning. It says Beth's glass of lemonade has a weaker tasting lemon flavor than John's. Let's write that on there. Hers is weaker. John's is stronger. If 2 ounces of water is added to Beth's, so we're going to add water to hers, and 1 teaspoon of lemon mix is added to John's, which glass will contain the lemonade with the stronger lemon flavor? Well, his was stronger to begin with. If you're adding more lemonade mix, hers was weaker to begin with. You add more water. I think John's will be stronger than Beth's because, of course, you're adding more because you're adding to an already stronger lemonade. Sorry for my less than nice handwriting. In this lesson, also, you're going to hear the word diluted. When you dilute something, you make it less strong or weaker tasting. So don't be afraid of that word diluted because that's kind of what we're talking about here. Okay, let's keep going. Number 2. It says Jimmy and Jake have glasses of lemonade that taste the same. All right. Same great taste in each one. If 1 teaspoon of lemon mix is added here and 1 is added here, which glass will contain lemonade with the stronger lemon flavor? Go ahead, think about that for a second. Write down why you think so. All right, I hope you said that Jake's is stronger because, that's my shortcut for because, he has less liquid to dilute the lemon. So there's hardly any liquid in there already, and then you add more to it. It's going to be a stronger tasting one than this one that has more or more liquid to it, adding more lemon. What about C? Jake's glass of lemonade has a stronger taste than Karen's. Stronger and weaker. All right. If 1 teaspoon of lemon mix is added to Karen's and 1 ounce of water is added to Jake's, which glass will contain the lemonade with the stronger lemon flavor? So his is already stronger, so if he adds more water, it's going to be not as strong. Hers is weaker. If she adds lemonade to it, it's going to be stronger. But we don't really know how much. So we don't know how much weaker or stronger it is. So in this one, we have to say not enough info, not enough information, because we cannot make that determination without a few more facts being involved. Moving on to the next one, number 2. It says, choose the correct statement to complete each sentence and explain your reasoning. If the answer cannot be determined, explain why not. So like on that last one, we didn't have enough information. That might happen to you here too. I want you to pause this video and I want you to read A, B, and C, and try to answer each question to the best of your ability. I'll go over the answers with you, so no fear of getting them wrong. You can't be wrong, because if you end up being wrong, you can erase it and fix it, change it to the right answer. So go ahead and give it a try. Pause this now, give them a try, and then push play when you're ready. Okay, hopefully you have answers for all 3 of them. Let's start with A. It says, choose the correct statement to complete each sentence and explain your reasoning. If the answer cannot be determined, explain why not. If Luke plans to use 4 more tablespoons of orange mix today than he did yesterday to make the same amount of orange drink, his orange drink today will be what? Stronger, weaker, or the same? Well, if he's adding 4 more, it's going to be stronger. B. Excuse me. Dave and Sandy each made a pitcher of orange drink. Sandy's pitcher is larger than Dave's pitcher. Let's make a little pitcher here. Here is Sandy's, and Dave's got a little bit smaller pitcher. That's for Dave. All right, Sandy used more orange mix than Dave. So Dave's orange drink has a stronger taste, a weaker taste, or the same kind. Well, we don't know how much more orange drink. We don't know how much water is involved. So I think on this one there is not enough info for us to really make a good qualitative reasoning. Let's look at C. If a race car travels more laps in less time than it did yesterday, so today covers more laps, less time, the speed would be slower, same, or faster. If he's covering more laps, I think he's going a little bit faster. Moving on, comparing comparisons, activity 2.2. 6th grade students are making hot chocolate. Oh, that sounds good. To sell at the Winter Carnival. Each homeroom suggests a different recipe. So the HR stands for homeroom. You've got them 4 there. All of them have milk and cocoa in them. That T stands for tablespoon. This little chickie over here is saying that T stands for tablespoon, capital T. If ever in a recipe you see a little t, that one stands for teaspoon, just to kind of keep them straight. All right, so they got cocoa powder and they've got milk. All right. Consider the given recipes. Oops. Consider the given recipes to answer each question. Use reasoning to determine which recipe has the strongest chocolate taste, which recipe has the weakest. Show how you use ratio reasoning to order the recipes. Identify the ratios that you used as part to part or part to whole. And create a poster. We're not going to be creating a poster, so we just have to do these first couple. So we got to decide which one's strongest, which one's weakest, and we're going to try to use some ratios as we do this. Well, let's take a look at what we've got here so far. First one here, we've got, let's go cocoa to milk, all right? Because we want to know strongest would be the one with most chocolate, weakest would be the one with the least chocolate. So let's do cocoa to milk. We've got 3 cocoa to 2 milk. This one right below it, we've got 4 cocoa to 3 milk. On the other side here, we've got 8 cocoa to 5 milk. And we've got 7 cocoa to 4 milk. We have ratios there. All those ratios are part to part because we want to compare the cocoa to the milk. Now, if I'm going to write them like a fraction, I want to kind of treat them like a fraction, I think. In every single one, there's more cocoa than milk. 3 to 2, 4 to 3, 8 to 5, 7 to 4. In this one, 3 cocoa and 2 milk. Boy, those are pretty close. It's almost equal cocoa to milk. So's this one, almost equal cocoa to milk. All right, over here on this side, I notice the cocoa, there's 3 more cocoa than there are milk. And in this one, there's 3 more cocoa than there is milk. So just by looking at these two, I would say I could draw a line right down here. These two are going to be weaker because they're almost equal cocoa to milk. And these two are going to be stronger. So I can do that just by making some observations. But they do want to know which one is the strongest, which one is the weakest. So let's see. Looking at the weaker ones, they're different numbers. If I treat them kind of like fractions, I know that if I had fractions that would be equal to each other or the same denominator at the bottom, I could compare them very easily. So I might try to do that. I'm going to try to make the denominators of these fractions be the same. So I have 2 and 3. I got to find a number that both 2 and 3 go into. So I'm thinking 6. Okay, I know that 2 goes into 6, and I can get 2 to 6 by taking it times 3. So I can take the top by 3, and 3 times 3 is 9. Okay, so that's 9 cocoa to 6 milk. That'd be like tripling the recipe. Well, down here at the bottom, I can get to 6. I can get 3 to 6 by taking it times 2. And if I do that on the top, I get 8 cocoa to 6 milk. That's like doubling the recipe. So if I triple this recipe and double this recipe, now I have the same parts of milk, both 6 and 6. Well, if they're both 6 milk, this one has 9 cups of cocoa, or 9 cocoa tablespoons. This one has 8. So which one would be weaker would be the one that is less. This one should be the weakest cocoa because it has the least amount of cocoa to milk parts. This one's almost to half cocoa and half milk. So got the weakest. Now I just have to figure out the strongest. Okay, so I'm going to try to do the same thing that I did over the other side. And I need to try to find, make these both milk parts be the same. So I have to find a common denominator if they're fractions. So I'm thinking 20 for both of them. I'm thinking if I multiply 4 times 5, I could get 20. And so on the top, 7 times 5 would be 35 cocoa and 20 milk. I'd have to make this recipe 5 times to get to that. And up here on the top, I would take 5 times 4 to get to 20. So 8 times 4 is 32 cocoa. Little teaspoons in the way there. So I'd have to make this one 4 times, this recipe. So now I have equal parts milk, 20 parts, 20 parts. And on the top, I notice this is 32 tablespoons of cocoa to 35 tablespoons of cocoa. This guy has a little bit more cocoa than the other one, so this one is the strongest. So you may have answered this in a little bit different way than I would have, but I wanted to kind of reason my way through which ones could be weaker or stronger. And then I had to come up with a more mathematical way to know for sure. I could have taste tested them and come up with my taste test analysis, but this is a little bit more supported with facts, a little bit more about math. All right, so that is 2.2. Well, moving on. I think we're done. I think we'll skip 2.3 or we will get that done in class. So after this particular lesson is over, I'll be having you do the assignment that goes with this particular lesson, which is right here, assignment 1.2. Read all of the directions very carefully, please. Go ahead and do 1 through 5. And why don't you give these a try for some extra practice? And give these a try for some extra practice for that what you can do. 1 through 5 will be graded. All right, go ahead. Good luck.